Burn like a pro.
You know when you're making a cup of coffee or when you feel that perfect breeze at the beach? What if I told you that the exact same process is behind both? It's true. There's this incredible invisible thermal engine running all around us all the time, and we're about to see how it works. Now, this engine is powerful, but it's got one non-negotiable rule, a fundamental requirement for it to even start. It only works in fluids. And here's why. Think about a solid. Its particles are all locked into place, kind of like a crowd at a sold-out concert. They can vibrate, sure, but they can't actually go anywhere. But in fluids, and that means both liquids and gases, the particles are free to move around, to flow past each other. This freedom to roam is absolutely essential. Without it, the engine just can't turn over. So, we need particles that can move. Got it. But what's the spark? How does this engine actually kick into gear? Well, let's zoom in on the core mechanism, how simple heat creates some seriously powerful motion. It all boils down to one simple, fundamental fact. When you heat up a fluid, it expands. That's it. That's the spark plug. That one little thing gets this whole engine roaring to life. Let's look at what's happening on the particle level. You add some heat, and those little particles start getting super energetic. They vibrate like crazy, bumping into each other and pushing farther apart. So they end up taking up more space. Their volume increases. Now, if you have the same amount of stuff in a bigger space, that means its density has to go down. In other words, the heated fluid gets lighter. Okay, so hot fluid is lighter. So what? Well, this is where the magic really happens. This is how that simple expansion creates a powerful, self-perpetuating cycle. We're talking about the convection current loop, our engine running at full throttle. And here's how that loop works. Step 1, heat gets applied at the bottom. Step 2, just like we saw, the fluid expands and its density drops. Step 3, because it's now lighter than all the fluid above it, it starts to rise. Makes sense, right? Step 4, once it reaches the top, it starts to cool off, losing heat to its surroundings. Step 5, as it cools, the particles bunch back together, its density increases, and it gets heavier. And finally, step 6, what does heavy stuff do? It sinks. It falls right back down to the bottom, ready to get heated and start the entire trip all over again. That continuous cycle is the convection current. All right, so that's the science, but here's the cool part. You're actually using this principle every single day. You're pretty much a convection engineer, and you probably don't even know it. Let's see how this engine is at work in your own home. For example, ever take a look at your kettle and wonder why the part that heats the water is always at the very bottom? That's not a random design choice. It's brilliant physics. By heating from the bottom, you guarantee that the first water to get hot becomes less dense and rises. This movement forces the cooler, denser water from the top to sink down toward the heater. It creates that perfect rolling current that heats all the water evenly. I mean, if the heater were at the top, you'd just have a warm layer of water sitting there. And believe it or not, the same idea works in reverse. Think about an air conditioner. Why is it pretty much always installed way up high on a wall? You got it. It's the exact same engine, just running a cooling cycle. The AC pumps out cold air, which is more dense. It's heavier, so gravity just pulls it straight down. As that cold air sinks, it literally pushes the warmer, less dense air in the room up toward the ceiling, right back into the AC unit to get cooled. It's a natural and incredibly efficient way to chill an entire room. So this engine runs our homes. But it gets so much bigger than that. Let's scale things up, way up, and see how this same process powers our planet's weather, creating massive coastal engines. During the day, the sun beats down, and land heats up way faster than the sea. So the air over the land gets hot, expands, and rises. Well, nature needs to fill that gap, so the cooler, denser air from over the ocean rushes in to take its place. And just like that, you've got a sea breeze. Then at night, the whole thing flips. The land cools down fast, but the ocean holds onto its heat. So now the air over the sea is warmer and rises, pulling the cooler, denser air from the land out to sea. And that's your land breeze. It's a gigantic convection engine turning over day after day. So you see, it doesn't matter if it's a pot of water on the stove or the winds that shape our planet. It all comes back to that same invisible engine, that same simple, elegant loop. Heat expands, density drops, fluids rise, and the engine turns. It's a universal principle. So now that you know what to look for, now that you can see this invisible engine all around you, here's a question. Where else is it working? Think bigger. What about the churning molten rock deep inside the earth?
or the boiling plasma inside of a star. Once you start looking, you'll see this engine is running just about everywhere.